In this video, we're going to look at the sampling distribution of the mean and begin a discussion based on figure 6.14. However, we're going to use data somewhat different from the data in 6.14, which is length of stay for hospital discharges. We're going to look at data which represents the errors found in the recording of medical records. We see here the records, record 1, 2, 3, and so on. There are actually 600 total records, and along with the record is the number of errors that actually exist in that medical record. So the first record has no errors, the second has one error, and so on. There are 3 errors in the 8th. Going down, we can see there are 5 errors in the 22nd record, and though it's not shown here, the most errors in any of the records is 6. So the first thing I'm going to do is create a frequency distribution based on the mean and standard deviation of errors. So here I'll calculate the mean, and here I'll calculate standard deviation. The mean is equal to the average of all of the errors, and it turns out that on the average there are 0.776 errors per record. Then the standard deviation is STDEV, and since we will treat this as an entire universe of records, I'll put a P here to indicate that this is the population. Control-Shift down arrow, and the standard deviation is 1.173. Now I'm going to create a frequency distribution in terms of 1 standard deviation units around the mean. Since the standard deviation is actually larger than the mean itself, we know there won't be any observations in cells below the mean, so we're going to start here with 0, which indicates the mean. That is, anything less than or equal to the mean will be in this bin. Then 1, and I'll drag this down, and since it's clear that the standard deviation is so much larger than the mean, this will be skewed to the right, so we can't expect to include all of the data by 3 standard deviations above the mean. Now, this is equal to the mean, fixed with an F4, plus this standard deviation unit times the standard deviation itself, again fixed with an F4, and I'll click this all the way down. Now I'll put the frequencies here. First the data, Control-Shift down arrow, a comma, and now the bin values, Control-Shift enter. And here are the frequencies, and as we can see, they don't go out to 6 and 7 standard deviations. They only go to 5. So let's first of all see if we have all 600. I'll sum that column, and yes, we do have all 600 observations. And now let's look at the distribution. We'll ignore the 0 values in a graph. And if we look at the column graph, it looks like this. I'm going to go to Series and put the standard deviation units as the x-axis, and I'm going to finish this. And here is our chart, and it's possible to see that this set of data is heavily skewed to the right. That is essentially a replication of the same type of data that is shown in figure 6.14. but in this case, instead of being for hospital discharges, it's for errors in medical records.